Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today we are discussing about another important CSIR topic, so that is the residue under the complex analysis. Already I am informing you, every day I am teaching one topic from one CSIR old question I am teaching to you, right? So clear, now we are under the complex analysis. So from the complex analysis, elements of complex analysis, I told one question. And then according to your syllabus, analytical function is there. From analytical function also one question I took. And later Taylor series, and later subsequently I have to take Laurent series. After the Laurent series, a previous class poles, singularity, essential singularity, non-essential singularity, and removable singularity based on the principal part I told in previous class. Today we are discussing about the residue. So next topic is residue. It is very important topic to evaluate the definite integrals or the integrals easy to evaluate. We have to use the residue theorem. So what is the residue? How we have to use the residue? Once you have to see in GATE 2013 this question came. When this question came, GATE 2013 this question came in GATE examination 2013. This question asked, right? Once you have to see, for the function f of z is equal to, for the function f of z is equal to, I am solving the solution. How I am solving? Once you have to see, f of z is equal to 16z is divided by z plus 3 into z plus 3 into z minus 1 whole square, z plus 3 into z minus 1 whole square. The resident at the residue at the pole z is equal to 1. How many poles are there here? 2 poles are there, right? How many pole? How many principal part is there? Z is equal to minus 3, one principal part, and Z is equal to 1, another principal part is there. So their pole Z is equal to 1. Z is equal to 1. The pole is pole of order. What is the pole of order? Pole of order is equal to 2. What is the power is there? So that power we call it as a pole of order is equal to 2. But we know the principle. So what is the principle? If pole of order n, if pole of order n, then the residue of f of z is equal to a. F of z is equal to a, which is equal to 1 by n minus 1 factorial into 1 by n minus 1 factorial into limit z tends to a, limit z tends to a, d to the power of n minus 1 is divided by dx to the power of n minus 1, z minus a whole to the power of n into f of z. This is the principle for a pole of order n. But here our pole of order is equal to how much? Our pole of order is equal to 2. So that's why wherever n is there, you have to keep the 2. So then simply you have to find out the residue of corresponding that particular problem. Once you have to see, if pole of order is equal to, if pole of order how much? Pole of order is equal to 2. If pole of order is equal to 2, residue of f of z, z is equal to how much? F of z is equal to 1, correct? F of z is equal to 1. If n is equal to 2, right? The pole of order is equal to 1 by n minus 1 factorial means 2 minus 1 factorial, limit z tends to 1, z tends to 1, d to the power of n minus 1 factorial means d to the power of 2 minus 1, dx to the power of 2 minus 1 into z minus 1 whole square f of z. F of z you have to substitute here, right? So this is the principle for corresponding to our problem. Now you have to see the residue of f of z is equal to 1. The residue of f of z is equal to 1. The pole of order, how much? Pole of order is equal to 2. 1 by 2 minus 1 factorial is equal to 1 by 1 factorial. Limit z tends to 1. Limit z tends to 1. D to the power of 2 minus 1 is equal to d. D by dx of, which one we have to write here? Z minus 1 whole square into f of z is equal to 16z is divided by, what is the f of z? F of z is equal to 16z is divided by z plus 3 into z minus 1 whole square. Z plus 3 into z minus 1 whole square. So z minus 1 whole square. Instead of f of z, I am writing this one. So z minus 1 whole square, z minus 1 whole square get cancelled. So therefore what we have to write? 1 by 1 factorial, 1 1 get cancelled. Limit z tends to 1. Limit z tends to 1. D by dx of, there is a differentiation. How we have to write the differentiation? Z plus 3 whole square into z plus 3 into 16 minus 16z into which one we have to write here? Minus z plus 3 16 into minus 16 into which one we have to write here? So you have to take the 16 outside, or 16 also you have to keep. 16z into 1 plus 0. This is the differentiation of 16z by z plus 3. Correct? 16z by z plus 3. You have to take the outside 16, you have to take outside, right? Now what you have to do? So z is equal to 1 you have to keep. So if you have to keep 1 plus 3 in minus 1 plus 3 minus, which one we have to write here? Z is equal to 1 is divided by, here what is there? Once you have to take here, 1 plus 3 whole square is equal to 4 square. 4 square means 16. 16 get cancelled. Plus 1 minus 1 get cancelled. Therefore, how much you are getting? You are getting the value is 3. So, therefore, the f of z at the residue of z is equal to 1. How much you are getting the answer? Answer is 3. How simple it is. Just you have to remember the formula. You will get the answer. What is your answer? Option A is correct. Answer is 3. What is the pole of order? If pole of order is equal to n, the residue f of z is equal to a 1 by n minus 1 factorial. Limit z tends to a, d to the power of n minus 1 is divided by dx to the power of n minus 1 z minus a whole to the power of n into f of z. This is the formula for finding the residues. So very important. Like this course, so many questions they will ask. These residues will help you to find the evaluation of integral. Maybe tomorrow's class I have to teach you how we have to evaluate the integral by using a Cauchy residues theorem, right? So now, so this is the last two second topic. This one is, so if one topic we will finish the complex analysis in YouTube also. Already I am informing you, we started the CSIR and GATE physics online coaching, right? So if you are really interested my teaching, if you really likes my teaching, so you take my app and you purchase my app and you see our courses. Some demo classes also available in our app. Freely classes are there. You listen and you decide and you subscribe that course, and you enjoy to learn the mathematical methods of physics, or all the subjects, whatever the classical, quantum, electromagnetic theory is there, no? So those topic also you have to learn. Clear? So DL physics and JL physics courses also will available. So please concentrate on this. So if you have to take the course you want to take, because suddenly notification it will come, then suddenly they will conduct the exam. Within 50 days you are unable to learn the subject. From now onwards you have to learn. Maybe notification according to the job calendar, June or July it will come. Only 6 months is there. Within these 6 months you have to practice it. Then only one subject paper will complete. After notification you have to try to learn about the general science. So then only you have to crack the exam. Otherwise it is difficult to crack the exam. Thank you. So our courses will appear like this. CSIR and GATE physics course will appear like this. JL physics and DL physics. CSIR and GATE mathematical methods of physics. This mathematical methods of physics only recorded only, not live, only recorded. So this recorded course is available. Not only mathematical methods of physics, all individual topics also will available, but it will take the time. Now you have to purchase the mathematical methods of physics. Clear? So maybe couple of days we have to finish this entire portion also. Now we are under the last topics. So maybe so within 4-5 days we will finish this mathematical methods of physics. Please share and subscribe our YouTube channel. You have to learn through YouTube also. If you are not interested to subscribe our app, you have to learn our YouTube also. Thank you so much for motivated us. Thank you.